We're in the Czech Republic at the Sedlik Ossuary. It's also known as the Church of Bones. This church is decorated with the remains of tens of thousands of people from the Middle Ages. It is both spooky and breathtakingly beautiful. Much like quantum states though, it's neither until you observe it. Talking about quantum states, let's talk a little bit about quantum computing.
Secure Ninja.
Hey everyone, it's Andrew from Secure Ninja again. Today we're in Prague, the Czech Republic, and I'm here talking to Dr. Martin Svik from IBM. Dr. Svik, welcome to SecureNinjaTV.
Hi, good morning. Nice to meet you.
Nice to meet you too. So IBM is a world leader in quantum computing. Tell us a little bit about quantum computing, the benefits it has, and maybe some of the dangers it possesses.
Okay, so quantum computing is addendum to classical computers. It is currently working differently. It is about some quantum mechanics, and based on that you are able to do different type of computation. So it means that today we are able, with quantum computers, we are able to do quite complex algorithm solving that we were not able to do with the traditional ones. So some of the algorithms that we will not be able to compute in, let's say, millions of ages, but with enough qubits inside quantum computers, we will be able to solve it in minutes. So it means that this is such a big disruption of the industry.
Okay. What are some of the industries that are going to benefit from quantum computing?
Already today we know that we can use it, for example, for some complex mathematical, let's say just Monte Carlo or any other. So it means that here it excels. Then we are very good in material engineering, as well in pharmacy, and as well in machine learning. And the last one is a cryptography, because here, let's say, it excels as well.
Okay, cryptographic, now that's very interesting. We've heard a lot of talk about quantum computers being able to break our traditional algorithms. Now, how many qubits are we going to need to do that? Where are we now, and how long will it take until we're able to use quantum computers usefully to break our traditional encryption?
Okay, so you would be maybe surprised that, let's say, just that it's not so far away as anyone, let's say, could imagine. So we are not talking about tens of years. We are talking about, let's say, maybe 2 to 5 years, and everything depends on the computational power. Nevertheless, let's say our quantum computers are being based on freezing, let's say, near to zero. So it means that, let's say, we are talking about error correction and noise that we need to go down. Today we are having quantum chips around 127 qubits. Let's say until end of the year it will be 433. Beginning of next year or during next year it will be 1000. And in a couple of years from now we are talking about a couple of thousand, tens of thousands. For being able to decrypt some of these algorithms that are, let's say, 2048-bit long, we might need around 8,000 qubits. So everything depends on this error correction, let's say noise correction, and how quickly we will get there regarding number of qubits. But if we will be able to solve it, then let's say we might be able to succeed, let's say, applying, let's say, just Shor or Groover's algorithms.
And how long until we get to about 8,000 qubits do you predict?
Okay, so hard to say. Nevertheless, as we see that many IT companies are now investing into this area, we are moving dramatically forward with this error correction that is the biggest inhibitor. So we might say that it can be something like, let's say, 3 to 5 years, but depends on, let's say, many factors.
Yes, and hopefully the blockchain community as well is able to use the new encryption standards as well to secure the blockchain. IBM, as I said, is a world leader in quantum computing. What kind of free resources does IBM provide for people who are interested in quantum computing?
Okay, so this is one of our biggest advantage, because currently it's not only about having physical computers, but as well we are trying to look into that, let's say, to build a community around it. So what has happened, IBM has currently developed special toolkit named Qiskit. This is, let's say, available on qiskit.org, and here, let's say, anyone can download it, install it, and use it. Immediately, when you are just using that, you are able to use free of charge, let's say, 5-qubit computers, and you are able your algorithm to run it on that. You can use simulator or physical 5-qubit computer, and based on that, you can immediately see the results. If you would like to do it, let's say, a little bit less development, then we have low code, no code, let's say, solution, and this is Quantum Composer, and this is currently available as well on IBM pages. So if you put, let's say, Quantum Composer into the Google, you will immediately find it as the first line.
Excellent. Well, lots of free resources there. Of course, we'll have the links in the description below. Dr. Svik, thank you very much for talking to us today.
Thank you.
Hey guys, thanks for watching. We have a lot more content coming from the Czech Republic, so please remember to subscribe and like, and we'll see you back here at SecureNinjaTV again soon.